Hello there, gamers, and welcome back to another epic episode of Inexorable videos. In this video, we're taking a look at the difference of two squares and how we can factorize them. You might have seen this again in GCSE. I'm not sure. I'm going to pretend that you haven't. If you're comfortable with this, if you're familiar with it, then by all means just skip the video. But we're going to be pretending that you have never seen this before. Okay, so let's get straight into it. The first thing that we need to do is prove this, okay? Now, first of all, you might have seen this. Do not be scared, basically, by this sign here. This is called the identity symbol. You know what an equal sign looks like. It's just two lines. This is an identity sign, and it's three lines. What that means is it means that for any number, x or y, this is always true. Always, for any number, any situation, this is always true. If you've done trigonometry before, you'll know that sine theta over cos theta is also identical to tan theta. Always true in any situation, so that's why we use it. You can pretend that it's an equal sign though if you're confused by it still. You can just say that that's two lines equal sign, not a problem. Anyways, let's prove it. Okay, we're going to start with this side because this is easier to do it this way. So we're going to say x plus y, x minus y, okay? X plus y times x minus y. Let's expand. Let's just use our basic expanding that we should be quite good with by now. Let's do it. FOIL. First numbers, x times x, x squared. Outside, x times minus y, minus xy. Y times x, add xy. Okay, so y times x is xy or yx. I'm going to write it as xy, so it's easier to see that these terms can add together with each other. Okay, they're the same sort of thing. Finally, last, y times minus y is minus y squared. Now, you might be seeing it already. It turns out that and that cancel out because this is negative, this is positive, they're the same, so they must equal 0. It's like minus 5 plus 5, or minus x plus x. These two are going to cancel out, and we get left with x squared minus y squared. Okay, so we've shown that this is indeed equal to this. That shouldn't be too difficult to sort of get your head around. That's not really much of a problem. I'm going to leave this on the board anyway. But we're going to do some questions and we're going to look at how we might be able to solve quadratic equations using this. Okay, so here's a question. We want to factorize 16x squared minus 49. Now initially, you might be looking at this and thinking, there are no common factors, you can't factorize that. Because, okay, you can't take an x out because there is an x squared there, so there's two x's timesing together, but there's no x's in here, so you can't take an x out. It also turns out that 16 and 49, as far as I can think, do not have any common factors. So you can't actually do much with this. You can't take anything out. There is a way we can use this formula. So let's put it into this form here. We're going to start with this side. We've already got the difference of two things, but we want to rewrite these as whole terms being squared, because I know there's an x squared there, but I want this whole term to be something squared, okay? So, what's the square root? Let's try and take some square roots here. What's the square root of 16x squared? The square root of 16 is going to be 4, and the square root of x squared is going to be x. So I'm going to write 16x squared as 4x all squared, okay? Because that will turn into 16x squared, okay? Then I'm going to take away, I know that 49 can be written as 7 squared, so I'm going to take away, I'm going to put it in brackets too, 7 squared, okay? So now, this is in the format for the difference of two squares. There's a square, there's a square. So our x here is actually 4x, and our y is actually 7. So all we've got to do is I'm going to stand on this side because I feel like I'm going back and forth. All we've got to do is go from here to here. If you know what your x's and y's are, it's not a problem, right? So let's go for it. Let's say, so x is 4x and y is 7. So I'm going to say this 16x squared minus 49 is, I'm going to use the triple sign, the identity, just to show you that they are always equal to each other. 16x squared minus 49 is identical to 4x plus 7. That's basically our x plus y, times, that was an awful, I'm going to rewrite that, times by 4x minus 7. That's our x minus y that we can see there. Okay. Now this is identical to this, which means take any value, anything you want, any number, and put it where x is. This and this will always be equal, all the time. Choose any number you want for x, they're always going to be the same, identical to each other. Don't believe me, let's expand this really quick. 4x times 4x is 16x squared. Outside, 4x minus 7 is minus 28x. Inside, 7 times 4x is plus 28x. And finally, 7 times minus 7 is minus 49. Hopefully you can see that minus 28x plus 28x is 0. So bang, bang, we get left with 16x squared minus 49. Boom. Okay, so this is true. Again, this isn't actual working, this is just making sure that we're right, which we are. I'm just showing you guys. But we don't actually need that. This is what we want. So if you need to take the difference of two squares, we're right here. Now, this is the application to quadratic equations. I'm going to make some space here. We'll use the same question again. I'm going to say, what if that this was equal to 0? Okay, solve it. What's x? You could run into a problem if you try and do this. I'm going to say that implies, that's the implied sign. We're learning some new signs today, guys. The arrow, this just sort of means therefore, okay? So we're going to make a statement, 16x squared. If we add 49 to both sides, that will become 0, and we'll have plus 49. So we go 16x squared is then equal to 49, okay? All we've done is we've added 49 to the left and the right side, okay? So we get 16x squared equals 49. Therefore, x squared is equal to 49 over 16. Therefore, x is equal to plus or minus, let's take the square root of this whole fraction. Remember, when you take a square root of a fraction, you just square it at the top and the bottom and keep it as a fraction. So 49, the square root of 49 is 7, and the square root of 16 is 4. So plus or minus, make sure that it doesn't look very clear actually, plus or minus, positive or negative, 7 over 4, okay? Yes, technically that's fine, you're right. But we can also do it this way. If we set this equal to 0, we're kind of being chilling right now, because you'll notice that if we say 4x, that does not look like a 4 at all. If we say that 4x plus 7, using our normal methods here, is equal to 0, I'm going to do an arrow just to show where this is coming from, and 4x minus 7 is equal to 0, we end up with 4x is equal to minus 7, because we're taking 7 from both sides, and we end up with 4x is equal to 7, because we're adding 7 to both sides. That means x is equal to minus 7 over 4, and x is equal to positive 7 over 4. So this definitely holds. This is going to give us the same solutions that we would normally be looking at. So it is totally valid to solve a quadratic equation. Remember, quadratic equation is something with the something squared, a variable squared, normally an x, using this method of the difference of two squares. There are actually quite a lot of applications of doing this with this method. I think it's really nifty actually, but this is the general gist of it. This is all it is. This also is the reason, this formula here is the reason why rationalising the denominator works. Because let's say that this is some denominator, x plus y, maybe it's like 1 plus root 5 or something. We agree this is the conjugate of 1 plus root 5, right? It's 1 minus root 5, if we pretend that that's a 1 and that's a root 5 for a second. If we do this, we can say that this, and we've already proved this formula here, we can say that this is equal to this, and this is two things that are being squared. Two things that are being squared are going to be rational if they're being taken away from each other like this or added together, because even if we have a root here, it's a square root being squared. So if it was this, let's say we had 1 plus root 5, as I say, 1 squared is 1, and root 5 squared is 5, so it would end up being 1 minus 5 on the bottom, which would be minus 4. So we can see how in every case, this is why rationalising the denominator actually works. I challenge you actually to try this, have a go at more rationalising the denominator questions with this, bearing this in mind. Just, this is why rationalising, because some people don't get rationalising the denominator. They don't see why do we times by the same thing as what's on the denominator, but with a different sign? Why do we do it? It's because of this formula. This formula is the reason why we do it, which is really interesting. Anyways, guys, thank you so much for watching this video. Please stick around to see the next videos. We are about halfway through, maybe actually a bit less halfway through quadratics at the moment, but you can quite clearly see there can be harder questions on this. You can get things that involve powers of like 4 and stuff like that. But yeah, I urge you to just try some questions and see how it goes. Anyways, guys, thank you for watching. See you in the next one.